An IPv6 address is a 128-bit address written in colon-separated hexadecimal notation. An IPv6 address can be represented by 128 binary digits, like this, but more commonly, it's represented as colon-separated hexadecimal notation. Each hexadecimal numeral in an IPv6 address is the equivalent of 4 binary digits, or 4 bits. An IPv6 address is composed of 8 colon-separated hextets. We can see the 8 hextets here, separated by the colons. An IPv6 address has a network prefix. In this address, the network prefix is /64. The network prefix is in decimal, not hexadecimal notation. And the purpose of the network prefix is to identify the number of bits in the network portion of the address read from left to right. So in this IPv6 address, the /64 means there are 64 bits in the network portion of the address identifying the network. The remaining 64 bits are the host identifier bits and represent the host computer. An IPv6 address can be represented in a compressed format. In other words, leading zeros, meaning the zeros to the left, can be omitted. In this IPv6 address, we can see the following zeros highlighted in red are on the left side of the hextets. These zeros can be omitted, like this. Also, a continuous grouping of 4 zeros or more can be expressed as a double colon, but the double colon can be used only once per IPv6 address. In this situation, we can see that there are 7 zeros towards the center of the IPv6 address. These 7 zeros can be compressed and represented as a double colon. A loopback IPv6 address in compressed format looks like this: :1/128. In this address, the /128 signifies a network of only 1. Uncompressing this address, we can see that we now have 8 hextets with the 1 at the end on the right-hand side, /128. You can see how much easier it is to write the address in the compressed format. Let's practice uncompressing an IPv6 address. We have the following address. The first thing we'll want to do is identify the hextets with leading zeros that have been omitted. Here is that same address, but with the leading zeros put back into the address. Notice how we currently have 4 hextets with a double colon. This signifies to us that there are 4 hextets of zeros that need to be replaced if we're going to uncompress the address. We simply replace the double colons with a grouping of 4 hextets of zeros, and the address has been uncompressed. It's also useful for certification exams to be able to identify bad IPv6 addresses. In the address at the top, we can see that the address has 2 sets of double colons. This is a bad IPv6 address. The middle address is also a bad IPv6 address because it only shows 6 hextets and there's no double colon to signify the missing hextets. So this is a bad IPv6 address. And the final address is a bad IPv6 address because it contains an H and a J. An H and a J are bad characters in hexadecimal notation. Hexadecimal notation goes from 0 to 9 and A, B, C, D, E, and F, with F signifying the number 15.